right, well, thank you, welcome, and thank you for being here. Today, we are going to look at vegetative changes within the areas of critical environmental concern in the Taos and Rio Arriba counties of northern New Mexico. The study period is between 2000 and 2020. And, oh, there we go. I just want to say thanks to my family and friends, really for their support in this. It's been a long road to grad school, and I really would like to thank my advisors, Kathleen Landine from undergrad and Jennifer Mason from graduate, and all of my wonderful professors, really for their commitment and dedication to education and to specifically helping me navigate college life. It was a journey. And also to my dogs for reminding me to have fun and get away from the computer for a while. Climate change will likely lead to major changes in plant distribution and thus in biomes and habitats. Humans and other species will be affected as our ecology is intimately linked not only to climate, but to habitat availability. The goal here is to determine if the Bureau of Land Management's protective measures have helped mitigate the effects of climate change in this region. Our study area consists of 4 designated ASEC areas of critical environmental concern, or ASEC designated areas. And this includes the Taos Plateau, the Lower Gorge, Copper Hill, and Ojo Caliente. These 4 areas cover over 327,000 acres within the Taos and Rio Arriba counties. This is just a better view of the study area, and we can see the Taos Plateau to the north, coming down into the Lower Gorge area, Copper Hill over to the east, and then we have Ojo Caliente to the west. The Bureau of Land Management field offices prepare public lands land use plans for public lands. The development of these plans requires BLM managers to work closely with local, state, and tribal governments, as well as the general public. While the BLM was a partner in establishing strict regulations of ASEC lands, there is concern that they have not enforced those regulations. So this has left the areas open to land degradation due to climate change, human impact, and other detrimental forces. ASEC designations are areas where special attention is necessary to protect historical, cultural, and scenic values, along with the fish, wildlife, and natural resources within those areas. There are concerns that ASEC areas have high concentrations of oil and gas reserves, and development within these areas has gone unchecked. Livestock grazing is also destroying riparian areas and threatening protected species. Private lands are encroaching on ASEC areas and fragmenting viable habitats, and water quality in many of these areas has been compromised. The Rio Grande del Norte National Monument, which covers the Taos Plateau study area, was created in 2013 to preserve and maintain its diverse array of natural and scientific resources, and also to protect the cultural and geologic resources, as well as wildlife and the ecological diversity specific to that area. The Lower Gorge and Copper Hill study areas include the lower portion of the Rio Grande Basin, which is just south of the Taos Plateau. And the Ojo Caliente study area includes the Rio Ojo Caliente and portions of Rio Chama to the west. This site also contains four large Tiwa Indian Pueblo ruins that date back to 1350 to 1550 AD. Methods and data. Data was acquired, combined, cleaned, and organized. Vector and raster data was formatted using ArcGIS Pro. It was analyzed using NDVI and surface reflectance techniques, and it was compared over 5-year increments from 2000 to 2020. So the satellite imagery uses a path and row system to designate the images. And so I'm looking at path 33, rows 34 and 35. So using the composite bands tool from ArcGIS Pro, each of the 6 bands, 1 through 5 and 7, were combined for each raster in rows 34 and 35, creating 2 rasters for each temporal data set, 2000, 2005, 2010, 2015, and 2020. So this brought my, I started with about 60 rasters, and doing the composite bands, it brought it down to about 10 rasters. Next, using the merge raster function, the rasters were combined for each path, which merged rows 34 and 35 for each data set. This brought the total of 10 rasters down to 5, 1 for each temporal period. The rasters were then clipped to the study area and analyzed with the NDVI colorized raster function. This process ran each of the 5 data sets using bands 3 and 4 to create a clipped color map specific to the study area. And so you can see on the left here, my left, where these were the original rasters that we started with. And then afterwards, I had this clipped area color map to the study area. Vegetation strongly reflects near infrared, which can be seen in bands 4 of the Landsat ETM plus bands in the table. And that those are wavelengths 0.77 to 0.90. It also absorbs red light as seen in band 3, which is 0.63 to 0.69. NDVI, or the Normalized Difference Vegetation Index, measures the difference between near infrared and red light as shown in the equation. NDVI is the most common vegetation measure in remote sensing because healthy vegetation has higher amounts of chlorophyll, which reflect more near infrared compared to other wavelengths. It also absorbs more red light compared to other wavelengths. And since Landsat satellites have both near infrared and red light bands, the NDVI calculation is a standardized way to measure healthy vegetation. NDVI rasters were compared between 2000 and 2020. You can see these are the ones that I started with after I did the clipping. I had that color map. So I started with, this is the Taos Plateau in 2000 and the Taos Plateau in 2020. And they were compared to determine the amount of vegetative change within each of the 4 ASEC areas. This was done using the DIF spatial analysis tool in ArcGIS Pro. This tool determines the difference in each raster and creates a new one depicting those changes. So that's shown here. This is the new raster that shows up. And we'll take a look. We'll take a look a little more at that. If values on the one raster are the same as the raster being compared, then there is no change. However, if the values are different, then the output determines the amount of change, which is shown in the new raster. The surface reflected data sets were each clipped to the study area for each of the 5 temporal periods. So they start out looking like this, and then I clip them to the study area for each period of time. Similarly to the NDVI analysis, diff spatial analysis in the ArcGIS Pro was used to compare any differences in vegetation between 2000 and 2020. As previously mentioned, vegetation reflects and absorbs different wavelengths of light, and so surface reflectance is used to measure the amount of specific wavelengths reflected from the Earth's surface. So the surface reflection and NDVI results were compared with the precipitation data, and the apparent vegetation fluctuations within each temporal period coincide with the fluctuations in average rainfall for those years. So we can see here that we have a higher amount of precipitation in 2005 and 2015, especially in the Rio Grande. And so when we're looking at individual rasters, we can see the vegetative increase on both of those years, and then the decrease here in 2010 as precipitation decreases. However, when we compare the vegetative data over a longer period from 2000 to 2020, then the vegetative change becomes much more apparent, and it shows an overall decrease in vegetation. So we can see here the difference in surface reflection between 2000 and 2020. The darker blue areas show little to no change, while the light blue to yellow to red areas show the amount of change between the 2 studied years. The greatest changes appear to be in the hilly region of the Taos Plateau, which we can see up here, along the Ojo Caliente River down here in red, and the eastern portion of the Copper Hill area here. NDVI comparisons show changes in the same areas. In the Taos Plateau, areas of the greatest vegetative decline seem to be in the hilly regions here and down into the scrubland. The least amount of change seems to be in the northern portion up here in blue. However, we don't have an accurate analysis due to the cloud cover in the satellite images. And I will talk about that a little bit later. Here, the comparison shows the decline throughout the lower gorge and into the southern portion of the Copper Hill. The greatest changes lie in the eastern portion of Copper Hill, as seen here in the red and orange. Both the surface reflectance and NDVI images are consistent with each other in showing the overall changes. In the Ojo Caliente area, vegetation has declined throughout the area, and the riparian system along the Ojo Caliente River, which we see here in red, has nearly disappeared. So we can see here that the Taos Plateau has lost nearly 30 square kilometers of vegetation. And the lower gorge in Copper Hill has lost almost 6 square kilometers, and in Ojo Caliente, it's lost over 10 square kilometers of vegetation, and this means habitat loss, essentially. Climate change, prolonged drought, and growth of human infrastructure are but a few of the conditions contributing to habitat loss. Management practices or the lack thereof, as seen in the BLM's ASIC designated areas of northern New Mexico, could also be contributing to these changes. Through the data analysis, we can see that there are significant changes in vegetative cover in all 4 ASIC designated areas over the study period. These changes, however, cannot be directly contributed to one specific issue and are most likely a result of many factors. So one issue that I faced with this project was with the Landsat 7 ETM plus images. In 2003, the scan line corrector, which is compensates for the forward movement of the satellite, it failed. And so the failure of that sensor caused striping issues within the images. I also had to deal with cloud cover in the images. And I tried to correct for both of those. However, I tried solving it through various techniques, but the issue proved to be too great for the scope of this project. So thank you for coming today. I appreciate it. And if you have any questions, I am open.